Hello and welcome. This is perhaps not a new problem because many of you must have solved it. But still, I'm doing my job. This problem is quite famous now, and this is related to coagulation of soap bubbles. Coagulation means merging the soap bubbles, and we have. Let me first read you the statement of the problem. That is, two spherical soap bubbles with different initial radii coagulate, and the radii of their free surfaces after the coagulation of R and R. No, their initial radii were capital R and small r. What is the radius of curvature of soap film that separates the two bubbles? What is the radius of this film's circular perimeter? So I'm going to solve it all. You can look at the picture on the right, and you must be wondering why there is a 120 degree. In this picture, I have just considered a very small portion of three surfaces, three spherical soap films, and since they are same soap films, their coefficient of surface tension will be same, and length is obviously same. So there are three forces acting at this point C, and the point C is in equilibrium. So that means we have got three vectors acting at same point with equal magnitude, and sum of this vector and their vector sum is equal to 0. So there must be angle between the angle between them will be 120 degree, nothing else. So this is the 120 degree doing here. If you wonder, you can see this angle will be equal to 60 degree because two lines are merging there and the angle between them is 120 degrees. So other angle will be simply 60 degree. And in this case, the tangent to this surface is this one, and this tangent to this surface is this arrow, and tangent to this surface is this. So the radii will be forming the same angle, 120 degree. But you can see here, this is the radius of two original soap bubbles, or you can say after their coagulation, the radii of new surface formed, and the angle between radii of new surface formed and the original bubble of radius r. This angle cannot be 120 degree because this angle is 120 degree. That means this angle is 60 degree. So this angle will also be equal to 60 degree. And like this, you can think about it. And though I don't have to do this much of calculation because it doesn't require in the first part of the solution. We all know that the pressure inside this bubble and the outside pressure is atmospheric pressure. So their pressure difference, we can simply write P1 minus P0 equal to P4 sigma by R. This sigma is the coefficient of surface tension, and in the same manner you can write here P2 minus P0 inside pressure between a smaller sphere initially and right now. A smaller sphere of radius is smaller, and outside pressure will be 4 sigma by a smaller. And in the similar manner, the gauge pressure or the excess pressure between the separating soap film, that is this, and its radius is rho. I have just assumed it, so that you can simply write here the pressure difference between P2 will be at larger, P2 will have a larger value. So you can write, and this surface is separating separating soap film. It will have a pressure difference, and its shape is like this, in this manner. So P2 will be greater than P1, and you can write here simply by P2 minus P1 is 4 sigma divided by a radius of curvature of this separating soap film. And after doing all those things, all these equations, writing all these equations, you can simply calculate that the value of rho will be simply r multiplied by r minus r, the radius of curvature of the separating soap film. And yeah, so first part is being solved. Now we need to solve the second part. And to solve the second part, I earlier told you that this angle will be 60 degree and this will be 30 degree, because since this is the angle bisector of 120 degree, this line, this arrow is the angle bisector of 120 degree, so it must be the angle bisector of 60 degree as well. So this whole angle is 60 degree and this angle is 30 degree. And now you will be needing to find out this length, because we finally need to find out this length A indicated in this picture. This A, the radius of the circular perimeter of the soap film, separating soap film. So do nothing, you can apply cosine formula here, and you can write AB square equals R square plus R square minus 2RR cos 60 degrees. Simply cosine formula is this, so we can write a cosine formula here, that is AB square equals R square plus R square minus 2RR cos 60 degree. And this is the first equation of the second solution of the second part. And you can write a sine formula for this triangle, and that is sine theta divided by a small r and sine 60 divided by AB. So you can write here sine theta by sine 60 degree, and that will be equal to r by AB. So you calculate your AB from here and get the value of sine theta. And after getting the sine theta, you can simply write A, the radius is r sine theta. Radius of this separating soap layer is simply r sine theta. So you can get the value of r sine theta like this, root 3 by 2 rr divided by under root r square plus r square minus rr. And that's, I think, is the simple problem. And if you like to consider something, some special cases, you can consider what happens is if r tends to r. I guess in this case, rho tends to infinity. You will find it soon, find by yourself. And or what happens if r is much greater than r, and what if r is equal to simply 2r. Another, there are many cases people discuss. You can discuss them all. Thank you very much for watching.